So in our lesson, we're still going to be learning about solving equations, but we're going to focus today on equations that kind of break the rule. So what I did was I gave you a warm-up as an introduction to these rule-breaking equations. So in this first example, we need to find the value of x. And so the question says, well, it says first off, what's going to be the first step? What would I do to get x by itself? Now, we have x over 3 is equal to 10. So you have to ask yourself, well, what's keeping x from being alone? Division. We're dividing by 3. And to undo division, we have to do the opposite. So for this one, there's actually just one step involved. So to get x by itself, we would multiply both sides by 3. So I set it up. So 10 times 3 is 30. The 3's cancel out here. And I'm left with x is equal to 30. Well, if you go back and you check yourself, what is 30 divided by 3? And it's 10. So it checks out. Okay? So always think opposites. Anytime you have this fraction bar like this, that indicates division. The opposite of division is multiplication. So we multiply both sides by 3. Well, what about this second problem here? 5x over 3 is equal to 10. You see, now we've got more than just one step involved here. Well, nothing has changed. Our first step is still going to be to multiply both sides by 3. But Miss Greene, that breaks the rule because you said that division and multiplication is always going to come last. Yeah, I did say that. But if you go back to the notes from the first day, if you remember, the very first step is to get rid of grouping symbols. Well, if you remember, that division bar is part of the grouping symbols. So for this one, my first step is still going to be to multiply both sides by 3. To get rid of that grouping symbol. So now, the 3's cancel out because what is 3 divided by 3? It's left with 1. 5x over 1 is 5x. And so now what I have left is 5x is equal to 10. 5x is equal to 30. Screen, do your math right. And so now, what will we do next? Now we can divide both sides by 5. And so x is equal to 6. So this one took 2 steps. So we had to multiply by 3, then we had to divide both sides by 5. So now let's take a look at the third one. So now this one's a little different. Okay, so if you go back and you look, notice how I've got this plus 15 thrown in here. And it's like it's got an extra thing here, okay? So if I want to multiply it as my first step, well, that's okay, but you got to be careful because do you see how this 15 is not being divided by 3? And do you see how this 15 is by itself? So what I would actually like to do is I want to make it as simplistic as possible. So this is one of those ones where I am technically going to break the rules a little bit. And it's not that I'm breaking the rules. I'm just breaking that 5-step process. So on this one, I'm going to start by getting constants together. Remember we talked about constants on one side and variables on the other. And that's exactly what I'm going to do. So I am going to subtract 15 from the 10 and cancels out here. And then now I'm going to have 5x over 3 is equal to 10 minus 15 is negative 5. Now I can multiply by 3. And so the 3's cancel out, leaving me with 5x is equal to, whoops, gotta put the 3 over here, negative 15. And then I'm going to divide by 5. So negative 15 divided by 5 is negative 3. So 5's cancel out, leaving me with x equals negative 3. Now, what if I said there's another way we can solve this one? So let's go back. If I had 5x over 3 plus 15 is equal to 10. Mathematically, am I doing anything wrong if I multiply by 3 first? And the answer is no. I can have my first step to multiply by 3. But what you have to be careful is you want to multiply everything by 3. So what I do is I set up a big group of parentheses. Okay? And what I'm doing is I'm multiplying by this common denominator. You see the common denominator here is 3. So it's like distributing through. It's like trying to cancel out with fractions, okay? So if I do that, what happens is these 3's cancel out, okay? So the 3's cancel out here, or if I look at it as a fraction and I say 5 over 3 times 3 over 1, and you multiply the tops, you get 15 over 3. What's 15 divided by 3? That's 5. Well, that's the exact same thing. You see, 3 times 5x is 15x. 15x divided by 3 is 5. So those 3's are canceling out, leaving me with just the 5x. But I have to also multiply the 15 times 3. So 15 times 3 is 45. And then I have to also multiply the 3 times the 10. So 3 times 10 is 30. So now the fractions are completely gone. So now I can start moving my constants around. I can subtract the 45 from the 30. So then I have 5x is equal to negative 15. And then the last step, divide by 5. And x is equal to negative 3, much like what we did before. But if you had just done what we did to start with and just got the constants on the same side together and just subtracted the 15 to start with, then it would have saved yourself a lot of time and fewer steps. In the end, guys, before you can ever get x or whatever variable by itself, you want all the constants on one side and all the variables on the other. Okay? Constants together, variables together. So now, let's take a look at example 4. Now, notice the difference here. So here, do you see how the 3 is underneath the 5x and the 15, whereas here it wasn't. Here the 3 didn't go with the 15. So because this 3 is with the 5x and with the 15, then in this one, I don't have any constants that I need to move. I am going to do like I've been doing, and I am going to multiply both sides by 3. So when I do that, let me rewrite it. So when I multiply both sides by 3, those 3's cancel out, and then it's going to leave me with 5x plus 15 is equal to 30. Now, we're looking at different problems. You see, the reason why they're not going to come out and be the same is because of the fact that that 15 does not have the 3 underneath it like this one does. So we've got 2 different problems. So we're going to have 2 different answers. So now I can subtract the 15 from the 30. And then I have 5x is equal to 15. And then the last step, divide both sides by 5. And you have x is equal to 3. So depending on the way it's set up, depending on where the fraction bar is, if it's a long bar or a short bar, if the 3 goes with both or if the 3 just goes with one of the terms, that really is going to determine your steps and your process. So what about this one? What would be the easiest first step? So again, we've got this bar, this long bar, but do you see how the 3 goes with the 5x and the 15? It does not go with this minus 25. So my first step would be to add 25 to both sides. And so now I have 5x plus 15 all over 3 is equal to 35. So then next, what am I going to do? Well, now that looks a lot like what we did over here. So now I'm going to multiply both sides by 3. So now the 3's cancel out, leaving me with 5x plus 15 equals, all right, so what's 35 times 3? 105. Then subtract the 15 from the 5. So 5x is equal to 90. Then last, divide 90 by 5. And x is equal to 18. So in the end, the reason why these are rule-breaking equations is because in our 5-step process, I said division and multiplications almost always last. But sometimes you got the exceptions to the rule. Sometimes you got to multiply first. Sometimes you got to get the constants together first. You want to just look at the problem and decide what's going to be the easiest, okay? Does that fraction bar go with everything or just a little bit? If it goes with everything, then you're going to multiply first. If it just goes with part of it, you want to get the constants on the same side first. So we're going to look at some examples and see what to do. And again, a lot of it's just every time ask yourself, is x by itself, what step needs to come next? What I do to one side, I have to do to the other. And always think opposite.